Use the graph of the function to find its domain and range. Write the domain and range in interval notation. First, let's recall that the domain is a set of all the x values in the ordered pairs in the function, and the range is the set of all the y values in the ordered pairs in the function. So in our first graph, we see a semicircle that, in a sense, starts at the point -7, 5. It decreases to the point -3, 1, and then it increases to the point 1, 5. So we can identify a couple of specific points easily on the graph, but what we need to understand is that there's really a bunch of points along this curve, and that the graph represents all of the points on the curve. So we need to not just focus on the specific points that we see, but all of the points along the curve. So when we're asked to find the domain, what we want to do is, in a sense, start at the beginning. Start the furthest left that we see. So the leftmost value that I see on the curve is -7, and the rightmost value that I see on the curve is +1, and it appears to be connected between. And so there's a bunch of points going from -7 to +1, and all of those are the x values for the curve. So then the domain starts at -7 and goes to +1, and it appears to include the endpoints, so we'll use brackets on the -7 and the 1. For the range, the minimum y value that I see is 1, and the maximum y value that I see is 5. And it appears to be connected between, so I get all of the values between 1 and 5. So the range of this function appears to be bracket 1, comma 5, bracket. In general, when writing the domain, we think from left to right, and for the range, we think from bottom to top. Let's see another example. In the second graph, we see a curve that starts at -2, 2. It increases for a while, gets to sort of a high point, and then it decreases, gets to a low point, and then increases again and ends at the point 4, 2. The domain for this curve, from left to right, the minimum x value that I see is -2. The maximum x value that I see is 4, and it's connected in between. So the domain is -2 to 4, with brackets on each endpoint. The range, the minimum value that I see appears to be at -3, and the maximum value that I see appears to be at about 7. So I'll write the range, and it appears to be connected in between. I get all the values in between. So the range is from -3 to 7, and I'll bracket each of those endpoints. Let's see a couple more examples. In the third graph, I see a curve that has a definite starting point at 3, 4, and then it increases as I move to the right, and I see an arrow that's to the right as it's increasing. So this curve does not have a finite domain or range. This curve, for the domain, I see a minimum value of 3, and I can keep going to the right. So the domain for this curve is from 3 to infinity. Now recall, whenever we write an infinity with interval notation, it always has a parenthesis next to it. Similarly, for the range, the minimum y value that I see is 4, and I can get any y value higher than that as an output. So the range for this function is from 4 to infinity. And the last curve we see has arrows to the left and to the right. So I've got an arrow to the left, I've got an arrow to the right, and what I see is, and the curve itself from left to right is decreasing the entire way. It's always moving downward as I move from left to right. So this curve is decreasing from left to right, but I can continue to the left as far as I want. I can continue to the right as far as I want. So for the domain, there's no minimum and there's no maximum. I can use the entire number line, the x number line, for the domain. So the domain of this function is from negative infinity to positive infinity. I can use any x value for this function. Then for the range, I see this, if I look at the arrow to the right, it's continuing downward as I move to the right, so I can get any negative y value, and it's connected between. And if I look at the arrow to the right, to the left, it's continuing upward to positive infinity as I move to the left. And so I can get the entire any y value in the range. And so the range is also negative infinity to infinity.